35 men gone in a morning. That's what the Yellow Jacket mine fire cost on April 7th, 1869. But the fire didn't kill them. The hoist did. Or rather, the lack of one that could move fast enough to get them out before the poisonous gas filled their lungs. The American winding engine, what miners called a hoist, stood at every major mine shaft from Nevada's Comstock lode to Pennsylvania's anthracite fields, a steam-powered giant that could lift 1,000 pounds of silver ore from 3,000 feet down or drop a cage full of men to their deaths in under 30 seconds. This is the story of the machine that built American industry and killed the men who trusted it. It was an engineering marvel. It was also a gamble every single shift. Before we're done, you'll understand why American miners were the highest-paid workers in the world and why they needed to be. We're going to find out how American engineers conquered depths the world had never seen, how a single hoist failure could bankrupt $1 million operation overnight, and why rope accidents killed more miners in the Comstock than cave-ins and explosions combined. When America needed to go deeper, Silver built Nevada. By 1860, the Comstock lode was producing ore so rich it made California's gold rush look like pocket change. The ore assayed at thousands of dollars per ton, wealth beyond anything the 49ers had dreamed of. But there was a problem that no amount of money or ambition could solve with shovels alone. The deeper you went, the hotter it got. Water temperatures at 800 feet reached 100 degrees. At 1,500 feet, 120 degrees. At 3,000 feet, the deepest the Comstock would eventually reach, the rock itself was hot enough to raise blisters on bare skin. And you still had to get the ore out, and the men, tons of it, every day. In the early days, hand windlasses worked on shallow claims. A man cranked a drum, winding rope, lifting buckets of ore one at a time. Maybe 200 pounds per lift if you were strong, and the rope held. It was slow, it was exhausting, and it had a ceiling. You couldn't go deeper than maybe 60 feet before the weight of the rope alone made it impossible to turn the crank. Your arms gave out before the bucket reached the surface. Horse-powered whims came next. A horse walked in circles on the surface, connected to a capstan that wound the rope. Better. You could go deeper, lift more, but still not enough. The Comstock shafts were already punching through 200, 300, 400 feet, chasing silver veins that showed no sign of running out. That's where American ingenuity met British technology and said, "We can do this bigger." Steam-powered winding engines had been working British coal mines since the 1780s, invented by men like James Watt, who understood rotative power and continuous operation. But American mining engineers looked at those designs and saw limitations. Not powerful enough for our depths, not fast enough for our production schedules, not built for the kind of scalding heat and brutal conditions we're about to encounter. So, they engineered American versions. By the 1860s, every major mine on the Comstock had a hoist house perched at the shaft head, massive wooden or brick buildings housing steam engines with cylinders 3 feet in diameter and drums that weighed more than a locomotive. The Consolidated Virginia and California Mine, when it struck the Big Bonanza in 1873, the richest ore body in Comstock history, installed hoisting works that cost $300,000, more than most entire mining operations were worth. The first tests were calculated risks, not prayers. American engineers didn't hope. They calculated tensile strength, factored in safety margins that they thought were adequate, and bet the mine's future on mathematics and American steel. At one Comstock shaft in the early 1860s, they loaded the cage with 2 tons of ore for the maiden run. The engineman opened the steam valve. The drum began to turn. The rope, inch-thick braided steel, fresh from the San Francisco foundry, stretched tight, and the ore rose, at speeds no horse-drawn system could match. When it reached the surface intact, the mine superintendent didn't throw a party. He ordered the rope inspected for stress damage, the drum measured for any deformation, the steam pressure logged for future reference. It worked. Now make it work 1,000 times a day, every day, without killing anyone or shutting down the mine. The public's reaction was pure American capitalism wrapped in frontier excitement. Investors in San Francisco, where 10 times more stock was held in Comstock mines than in California gold operations, poured money into hoisting technology. These machines were massive, stories tall, employing hundreds. When they ran smoothly, fortunes were minted, stock prices soared, dividends flowed. When they failed, and they did with brutal regularity, the headlines were savage and the stock prices collapsed overnight. Before steam hoists, a horse whim might lift 500 pounds an hour from a 200-foot shaft. A good American hoist could lift 10 tons an hour from 2,000 feet. The Quincy Mine in Michigan's Copper Country eventually installed a hoist that weighed 880 tons and could lift 10 tons of ore at speeds approaching 16 meters per second from an incline nearly 3 kilometers deep, the largest ever built. The revolution wasn't just about speed, it was about depth. American mines went deeper faster than anywhere else in the world because the hoists made it economically viable. And American miners died faster than anywhere else because when those hoists failed at those depths, there was no second chance and no survival. But here's the trade that defined American mining: efficiency bought with danger, speed bought with risk. Push the machine too hard, and the rope snapped, or the brake failed, and men died. Push it too slow, and the mine went bankrupt while competitors gained ground. The hoistman stood in the middle of that equation with one hand on the throttle, one hand on the brake. They'd built the machines. Now came the harder part, making them work in hell. The iron beast of the West. Stand next to a working hoist on the Comstock lode in 1875, and the scale hits you first. The drum is 18 feet across at the wide end, 9 feet at the narrow end, a spiral-wound cylinder of cast iron that weighs more than 50 elephants. When it spins at full speed, hoisting a loaded cage from 2,000 feet, the ground shakes for blocks. Buildings half a mile away feel the vibration. The engine itself, 2 vertical cylinders, 30 to 42 inches in diameter. Steam pressure at 120 pounds per square inch on a normal day, 150 if you're pushing production quotas and willing to accept the risk. The pistons drive a beam. The beam drives a crankshaft. The crankshaft spins the drum coal to water, to steam, to piston, to crank, to drum, to rope, to cage. A chain of controlled explosions that either worked perfectly or killed someone. The rope was everything. Hemp was worthless. It stretched, rotted, snapped. By the 1860s, braided steel cable, hundreds of wires woven into cables 1.5 to 3.5 inches thick, rated for 8 to 10 tons, replaced it. In practice under constant load, exposed to heat that could reach 170 degrees at depth, moisture from underground water, and the relentless saw-blade friction of winding over the drum thousands of times a day, it weakened. Fast. Invisibly. A cable rated for 10 tons when installed might be down to 6 tons after 6 months of hard service. You couldn't see the fatigue developing inside the braid. The cable looked fine on the outside right up until the moment it parted under load and men fell. Here's the American impossibility. You're building a hoist to pull men and ore from depths no one in human history has ever attempted. The Comstock shafts went 3,000 feet down, half a mile straight down through fractured rock, through water hot enough to scald flesh, through temperatures that broke men physically and mentally. A cage loaded with 10 men and a ton of ore hanging on a cable 3,000 feet long. The rope alone weighed more than the load it was lifting. The stress changed continuously throughout every lift. The drum had to accelerate that mass smoothly without creating shock loads that would snap the cable like a guitar string. It had to hold it steady through the entire ascent as the weight shifted, and it had to decelerate it precisely without slamming the cage into the landing. The hoistman, what Americans called the headman or hoist operator, controlled all of this with two levers, the steam valve and the brake. The valve opened, admitting high-pressure steam to the cylinders, which controlled the speed and power of the lift. Open it too fast, and the cage lurched, shock-loading the cable. Too slow, and you wasted time, and every second counted when you were processing hundreds of tons per shift. The brake was a lever connected to wooden or iron shoes that clamped onto the drum's outer surface, with enough force to stop 20 tons of momentum in 30 seconds. The friction could ignite the brake shoes. Get the timing wrong by 2 seconds, and the cage either crashed into the pit bottom or shot past the landing. This wasn't happening in some controlled laboratory or well-maintained factory. The hoists ran in 110-degree summer heat, where the boiler room was a furnace and men passed out at the controls. They ran in winter cold, where the steam condensed in the pipes and turned the brake levers slick with ice. They ran 24 hours a day. Stop for maintenance, and your competitors gained ground. The hoistman worked 12-hour shifts with no backup. Just you, the machine, and however many men were in the cage at that moment, counting on you to bring them up alive. You watched a depth indicator and listened for bell signals. 1 bell, stop. 2 bells, lower. 3 bells, raise. 4 bells, men aboard. Miss a signal over the thunderous roar of the engine and pistons and someone died. Some of these hoists ran for decades. The Consolidated Virginia's hoist processed millions of tons of ore from depths approaching 3,000 feet from 1873 through the 1880s. One major hoist failure could shut down the mine for weeks. In the competitive Comstock environment, that meant financial catastrophe. But nothing that size under that kind of continuous stress, in that kind of brutal environment, stays flawless. American hoists were engineered to tolerances the British considered reckless. Faster speeds meant higher mechanical stresses. Deeper shafts meant longer, heavier cables. Bigger drums meant more powerful engines. More powerful engines meant more things that could go catastrophically wrong. And American engineers had missed the human factor. A hoistman working 12-hour shifts in 110-degree heat, making split-second life-or-death decisions hundreds of times per shift. That wasn't sustainable. Not for months, not for years. The accidents started piling up. The pattern became impossible to ignore, even for an industry that treated worker deaths as operating expenses. Running the beast in hell's conditions. The hoistman's day started at 4 in the morning. First task, boiler check, pressure gauge reading, water level in the sight glass, firebox inspection. If the fire had died overnight because the night crew got lazy or distracted, you rebuilt it from scratch with expensive imported coal. Nevada had silver and gold, but no coal, so everything burned in those boilers came by rail from California or Utah at premium prices. 4 tons per shift minimum to keep steam at operating pressure. Then the drum inspection, walking around it slowly, looking for hairline cracks in the casting that could propagate and cause catastrophic failure. Checking the brake shoes for wear, measuring what was left of the friction material, examining every visible inch of cable for broken wires, kinks, or corrosion. This was your life you were inspecting, along with the lives of every man who'd ride that cage today. Then you ran it. And running a Comstock hoist wasn't like running a Pennsylvania coal operation where you had backup systems, multiple shafts, and unions pushing for safety regulations. In Nevada, you had 1 hoist, 1 rope, 1 shot at getting it right every single time. The mine owners made that clear when they hired you. Keep it running, keep the ore moving, don't kill anyone if you can help it. The worst part of the job wasn't the technical difficulty or even the responsibility. It was the environment. In summer, With the Nevada sun beating down on the hoist house's metal roof and the boiler running at full capacity, temperatures inside reached 130 degrees Fahrenheit. Men kept buckets of water next to the controls. They drank continuously, gallons per shift. They soaked rags and draped them over their heads. They still ended shifts dizzy, nauseated. The hoistmen were paid better than any other workers in the mine, $4 a day when common laborers made $2 and surface workers made $1.50, because you simply couldn't keep anyone in that job without premium wages, and the job demanded absolute perfection under impossible conditions. You accelerated the cage smoothly from a dead stop, too fast, and the shock load could snap the cable or injure the men inside from the sudden jerk. You held it steady through the entire ascent, making continuous tiny adjustments to account for the changing weight distribution as more cable wound onto the drum. You decelerated precisely, timing the brake application so the cage settled onto the landing platform with barely a bump. Overshoot, and you smashed it into the headframe, undershoot, and it bounced violently. You did this hundreds of times per shift, every shift, for years, if you lasted that long. What broke? Everything, constantly. The piston rings wore out from continuous friction against the cylinder walls. The valve stems corroded from superheated steam. The brake shoes disintegrated under the relentless heat and pressure. The cable frayed, individual steel wires popping free like violin strings snapping. The bearings wore down, despite constant greasing. Every single component of the machine wanted to fail, and the maintenance crew's job was holding it together with scheduled upkeep, constant vigilance, and whatever they could improvise when proper replacement parts weren't available or took 6 weeks to manufacture in San Francisco. They gave some hoists names, not affectionate names like you'd name a favorite horse. These were warnings. The Yellow Jackets hoist earned its reputation separately from the mine itself, for the number of men who got stung by it over the years. At other operations, hoistmen referred to their machines as Old Unreliable, the Widowmaker, or the Gamble. The names weren't jokes or dark humor. They were acknowledgments of a truth everyone who worked the Comstock knew intimately. These machines killed people regularly, and working around them meant accepting that risk every single day you showed up. The maintenance nightmares were legendary throughout Nevada Territory. Bearings the size of dinner plates had to be greased every 6 hours without exception, by hand. While the machine was still running and the pistons were still driving, you crawled into the mechanism with a grease gun, packed the bearing with tallow, and crawled back out before the next piston stroke caught you. The heat from the steam and friction was intense. The noise made your ears ring for hours. One mistake, one moment of inattention, and you were dead before anyone could shut the engine down. Miss a greasing schedule and the bearing seized from friction. The hoist locked up, and if it locked up with a cage full of men halfway down a 2,000-foot shaft, those men were trapped until you freed it, which might take hours or days depending on how badly it seized. Cable inspection on heavily used shafts was practically a full-time job for dedicated workers. They descended in the cage weekly, sometimes daily during peak production periods, hanging over the side in a safety harness, running their hands along every single foot of cable from the drum at the surface all the way down to wherever the cage stopped. 800 feet, 1,500 feet, 2,000 feet. Looking for broken wires poking through the braid, feeling for kinks where the cable had been bent wrong or wrapped badly, checking for rust or corrosion eating through the strands. It took hours of monotonous, dangerous work. Your hands bled from the sharp wire ends, your arms ached from constant reaching, and if you found a bad section, a spot where too many wires had broken or the cable showed signs of internal damage, someone had to splice it or replace the entire cable. A splice job meant shutting down the mine for hours. Full replacement meant shutting down for days, threading thousands of feet of new cable through the headframe, attaching it to the cage, and praying it seated correctly on the drum. One misalignment, one twist in the cable, and it would saw through itself within a week of operation. For months at a time, the hoists ran without major incident. The Consolidated Virginia's massive hoist pulled ore from 2,800 feet, 24 hours a day, processing millions of dollars in silver. The hoistmen were the best in the business. Steady hands, nerves of absolute steel, reputations built on years of never panicking even when things went wrong. The miners trusted them with their lives. They had to. There was no alternative if you wanted to work the deep shafts where the real money was. And then came the days when trust wasn't enough and everything went wrong anyway. When the cable broke, the warnings were always there if you knew how to read them. Small things, subtle changes, things the experienced hoistman noticed but couldn't quantify or prove to skeptical mine superintendents. The cable felt stiffer than usual when you ran your hands along it during morning inspection. The cage jerked slightly on acceleration where it used to start smoothly. The drum made a new sound, a faint grinding that hadn't been there yesterday. You mentioned it to the mine superintendent when he made his rounds. He'd come out to the hoist house, watch a few runs, see nothing obviously wrong. "Keep an eye on it," he'd say. "Monitor it." They always said that, as if watching could stop steel from failing when its time came. July 1868, Yellow Jacket Mine, Gold Hill, Nevada. 3 men in the cage, ascending from 800 feet after a normal shift. James Griffin, Timothy Griffin's cousin, fresh from Cork, Ireland, and 2 other miners whose names the Virginia City newspaper wouldn't bother recording because they were just working men. The cage was at 540 feet, halfway to the surface, when it struck a stray timber protruding from the shaft wall. The impact wasn't massive, just enough to jerk the rope sideways and stress it at an angle it wasn't designed to handle. The rope snapped. The cage didn't fall in slow motion like in nightmares. It plummeted 260 feet in under 5 seconds. The sound of the impact carried to the surface, a thunderclap of metal on rock that every miner recognized instantly. Everyone knew what it meant. The recovery crew found the cage crushed nearly flat, folded like paper, the bodies barely recognizable as human. The inquest found the rope had been in service for 14 months. Industry standard at the time said replace every 12 months. The superintendent testified they'd planned to replace it the following month. The families of the dead men got condolences and nothing else. Timothy Griffin didn't work the Yellow Jacket again after they buried his cousin. 9 months later, on April 5th, 1869, he had a dream that stayed with him after waking. Something, a presence, a premonition, whatever you want to call it, told him clearly that if he entered the Yellow Jacket mine one more time, death was waiting. He took it seriously. He'd seen too much death in the mines to ignore warnings, even supernatural ones. Checked out of his boarding house in Gold Hill the next morning, quit his job at the mine, and started the 240-mile journey on foot to San Francisco that night. He left just in time, walked away from the best-paying job he'd ever had based on a dream. Turned out to be the smartest decision of his life. April 7th, 1869, early morning, Yellow Jacket Mine. The day shift was descending for work, while the night shift prepared to ascend. A fire had been smoldering overnight at the 800-foot level, probably started by a careless miner's candle left burning too close to the timber supports. The square-set timbering that kept the shafts from collapsing, a Comstock innovation that revolutionized deep mining, was also perfect kindling once it caught fire. The wood had been soaking in hot water for years, dried by underground heat, saturated with minerals. When it finally ignited, it burned hot and fast. No one noticed until the burning timbers collapsed, sending a massive blast of superheated air and poisonous gas, carbon monoxide, carbon dioxide, sulfur dioxide from the burning minerals through the Yellow Jacket and into the connected Kentuck and Crown Point mines. The 3 mines shared some drifts and airways for ventilation. That interconnection, designed to improve airflow, became a highway for death. The hoistmen at all three mines tried desperately to save whoever they could. They lowered cages to pull men out, running the hoists faster than was safe, ignoring normal protocols, but the gas moved faster than any hoist could run. Men descending in cages suffocated before they reached the fire level. Men trying to climb ladders in the shaft fell unconscious, plummeting hundreds of feet. The cages came back to the surface empty or carrying dead men, faces purple, eyes bulging, features twisted in agony. At the 1,000-foot level in the Crown Point mine, rescuers later found 9 bodies piled together in a drift, men who'd climbed to what they thought was safety above the fire and waited for a cage that never came. They suffocated, waiting slowly, knowing what was happening, unable to do anything about it. The final count took days to compile. 35 confirmed dead. 4 bodies never recovered, sealed in sections of the mine that were too dangerous to access even after the fire was brought under control. The rock in those sections stayed hot for 3 years. Most of the dead were Irish immigrants, average age just over 30. At least 4 left behind wives and children with no income, and a miner's widow pension of maybe $12 a month if the mine company felt generous. Most companies didn't. The Yellow Jacket fire wasn't technically a hoist failure, but it exposed the fundamental vulnerability that every deep mine faced. One way in, one way out, and if the hoist couldn't move fast enough, or the hoistman couldn't keep his nerve when chaos erupted and men were screaming and dying, the machine became a bottleneck, a death trap. The Comstock's hoists were brilliantly designed for efficiency and continuous operation. They could move ore all day without breaking stride, processing tons per hour. But they weren't designed for emergency mass evacuation. When seconds mattered, when panic was spreading and the shaft was filling with lethal gas, the hoist's limitations became fatal. They don't make them like that anymore, not the machines, and not the men who ran them. Where the titans rest. What did the American hoists accomplish? Everything. Without American hoisting technology, developed in Nevada and Michigan and Pennsylvania, deep mining as we know it doesn't exist. The silver that financed the Union during the Civil War, Nevada became a state in 1864 specifically to secure those silver revenues, came from shafts too deep to work without massive steam hoists. The silver that built San Francisco from a frontier town into a major city came up Comstock shafts, 1 cage load at a time. The copper that wired America's cities, that made the electrical revolution possible, came from Michigan's Quincy mine, and similar operations, hoisted from depths approaching 3 kilometers by machines that pushed the absolute limits of 19th century engineering. The coal that powered American industry from Pennsylvania to Illinois, that fueled the steel mills and the railroads and the factories that turned the United States into an industrial power, came up shafts where hoists ran day and night without rest for decades. Every ton of it touched by a hoist operator's hands at some point in the process. By 1900, American mines were the deepest in the world. The Comstock lode had reached 3,300 feet in the Mexican mine's Wens, deeper than any European operation had ever attempted. The technology developed there out of sheer American necessity and ambition: square-set timbering to prevent cave-ins, compressed air drills for hard rock, massive hoisting engines with unprecedented lifting capacity became the mining standard worldwide. Engineers from South Africa to Australia to Chile studied Comstock methods and copied Comstock machinery. American engineers didn't just adopt British hoisting technology. They fundamentally reinvented it, scaled it up, pushed it harder, made it bigger, faster, more powerful, and more productive. And, inevitably, more dangerous. Because American mining operated on different principles than European operations. European mines prioritized stability, longevity, worker safety mandated by stronger regulations. American mines prioritized production, speed, shareholder returns. The numbers tell the story. Pennsylvania alone, every 110,000 tons of anthracite mined cost one life. Every 360,000 tons of bituminous coal meant another dead miner. By 1898, Pennsylvania was producing over 100 million tons annually. Do that math. Hundreds of miners dead every single year, and hoist-related accidents, cable failures, cage crashes, men falling down shafts, accounted for a significant and steady percentage. But the legacy isn't just what the hoists built, it's what they cost in human terms. Thousands of miners fed into American shafts over half a century, year after year, shift after shift, trusting machines that had proven they couldn't be fully trusted. The hoistmen knew the risks. They'd seen the accidents, buried the friends, watched the cable snap. The mine operators knew. They'd paid the widows' pensions, replaced the damaged equipment, reopened the shafts, and kept producing. The miners themselves knew better than anyone. They'd felt the cage jerk, heard the ominous sounds, noticed the warning signs, and they all went down anyway. The hoistmen because $4 a day was more than they could make anywhere else, and the mines needed their expertise. The operators because millions in silver and gold and copper and coal were waiting underground, and the stockholders demanded dividends. The miners because $4 a day meant food on the table, rent paid, maybe even enough savings to eventually get out of the mines and start something better. That wage differential, double what surface workers made, quadruple what farm laborers earned, was the price the industry had to pay to convince men to take that cage into the depths every shift. The Comstock load peaked in the 1870s during the big bonanza years when the consolidated Virginia and California mines were producing silver so rich it seemed inexhaustible. Then it crashed in the 1880s as the ore bodies played out. The easy silver was gone, and going deeper meant hitting hotter water and more difficult conditions. The mines that had produced over $400 million in silver and gold, equivalent to billions today, went progressively silent. The hoists that had run nonstop for decades ground to a halt. Virginia City, which had boomed to 25,000 residents and been the most important settlement between Denver and San Francisco, collapsed to a few hundred diehards by 1900. The massive hoisting works at the Consolidated Virginia and California mine, the pride of the Comstock, visible for miles across the desert, featured in engravings and photographs sent worldwide, sat abandoned, rusting in the Nevada sun and wind. By the 1920s, electric motors began displacing steam across American mining. Smaller, cleaner, safer, more efficient, and most importantly, for cost-conscious operators, cheaper to run long-term. Coal-fired steam engines required constant feeding, constant maintenance, constant supervision. Electric motors required periodic maintenance and utility payments. The economics shifted decisively. By the 1950s, even the most conservative operations had scrapped their last steam hoists. The era of steam power in American mining was over. A few survived by sheer luck or deliberate preservation. The Quincy Mine hoist in Michigan, the largest steam-powered hoist ever constructed anywhere in the world, still stands as a preserved monument. 880 tons of iron, steel, and American industrial ambition. You can tour it today, stand next to the massive drum, read the informative plaques explaining how it worked and what it accomplished. It's quiet now, safe, rendered harmless by time and restoration. No one's afraid of it anymore. School groups visit, and children climb on the barriers around it while their parents take photographs. It's become educational, historical, quaint. Hard to imagine it once terrified grown men. Most hoists didn't get that dignity or preservation. They were cut up for scrap metal when the mines closed, their steel and iron melted down, and reborn as something else. Maybe rebar in a highway bridge, maybe part of a warship, maybe structural elements in a skyscraper. The hoist houses were demolished, the brick and timber sold off or repurposed, the land sold to whoever would buy abandoned mining property. In Virginia City and Gold Hill, some of the old hoisting works foundations are still visible if you know where to look. Circular depressions in the desert floor where the massive drums once sat, slowly being reclaimed by sagebrush and desert grass, filling with wind-blown sand. What replaced the steam hoists? Progress, American style. Electric hoists with automatic controls and safety interlocks. Sensors that detect slack cable before it kinks and causes failure. Brakes that engage in milliseconds instead of seconds. Backup systems that catch the cage if the primary system fails. Redundant cables. Overspeed governors. Emergency brakes. Modern mines move material at rates the Comstock engineers would consider physically impossible, with safety records that would make the old hoistman weep with envy and disbelief. The technology improved. The regulations strengthened. The industry learned, slowly and expensively, how to not kill its workers quite so regularly. But the fundamental principle hasn't changed at all. You still need a powerful machine at the shaft head. You still need someone willing to descend into the earth. You still need to trust that when the operator pulls the lever, the cable will hold and the brakes will work, and you'll come back to the surface alive. The legacy question isn't just what the American hoists built. The cities, the industries, the fortunes, the infrastructure. The real question is what they proved about American industrial culture. That Americans would go deeper, faster, and harder than anyone else in the world if there was money in it. That men would risk their lives daily for wages that offered a shot at something better than generational poverty. That progress and profit came first, and safety regulations came later, usually written in the blood of workers who died, proving the need for them. That every technological leap forward demands payment, and in American mining, that bill came due in human lives. The American hoists bought industrial supremacy and Western expansion and mineral wealth beyond imagination. They paid for it with the lives of the men who operated them and the men who trusted them every single shift. That's not metaphor or poetry. That's accounting. Add up the documented deaths over half a century of intensive mining. The cable failures, the brake failures, the fires, the gases, the human errors compounded by impossible working conditions and 12-hour shifts in extreme heat. And you get numbers that should give pause. Thousands of deaths, probably tens of thousands when you count all the operations across all the mining regions. We'll never know the exact total because in 19th century America, we didn't bother counting comprehensively until it became a public relations problem and reformers started demanding accountability. We look at a preserved hoist in a museum today and see engineering. Cylinders and pistons and drums and gears and cables. A relic of the industrial age, safely behind velvet ropes and protective barriers and informative plaques explaining how it all worked. But it's not just a relic of old technology. It's a monument to the men who designed and built these machines and pushed the limits of what was possible. To the hoistmen who operated them under impossible conditions and held men's lives in their hands every shift. To the miners who trusted them and climbed into those cages shift after shift, day after day, year after year, knowing the risks but going down anyway, because the alternative was worse. Every major building in San Francisco was built with Comstock silver that came up from the depths on those hoists. Every mile of copper wire that electrified American cities in the late 1800s came from deep mines in Michigan. Every factory that burned Pennsylvania coal depended on hoists to bring that coal to the surface day after day. The wealth that built the American West, the industry that transformed the United States into a global power, the infrastructure that enabled 20th century prosperity, it all came up those shafts one cage load at a time, lifted by machines that worked until they didn't. The hoists sit silent now across the old mining regions. The Comstock shafts are sealed with concrete and steel. The old head frames torn down or collapsed, the tunnels flooded or caved in. The ropes are long gone, the steam is cold, the drums are still. But if you stand where the Yellow Jackets' hoist house used to be, in Gold Hill, Nevada, if you close your eyes against the desert wind and really listen, you can almost still hear it. The hiss of steam under pressure, the groan of the drum bearing the weight, the screech of steel cable going taut, the bell signals echoing up from below, the voices of 35 men who descended into the earth one April morning in 1869 and never saw sunset. They don't make them like that anymore. Not the machines. We've built better, safer, more efficient alternatives. And not the men who ran them, because we don't ask that kind of sacrifice anymore. And we shouldn't have asked it then.